A.9.2, Part 1. Hi, everybody. Today we're going to be looking at exponential functions. They're a little bit different than our quadratic functions or quadratic equations where we create a parabola, although the growth does grow as quickly as that. And when it decays, it decays as quickly as that. And we're going to be looking at what that graph forms. Our essential question today when we're looking at exponential functions is how does changing the values of a, h, and k affect the graph of an exponential function? So first let's figure out what a, h, and k are. Okay? A general exponential growth function has the form function of x equals a times b to the x minus h power plus k. Okay? X, obviously the value of x when we're on our number line, or on our graph, the value of x as it goes higher, we're subtracting that x minus an h. B is greater than 0, I have that written down right over here. A, h, and k are all real numbers, right here, and a is greater than 0. Every value of b represents a different family of functions that can be transformed by changing the values of a, h, and k. So this can be changed when we, and yes, well, in the last lesson we were looking at taking a number to a certain power and then multiplying it by another number. We did a times b to the x minus h power. We've done that already. Now we're adding a k component to it. The general exponential decay function has the same form, but b has to be greater than 0 and less than 1. All right, our growth function is going to look like this, and our decay function is going to look like this. Okay, notice that at no point do these lines cross the x-axis. They stay infinitely positive, which is kind of weird, but you'll get used to it. All right, so here we go. Let's break in. We'll be doing part 1. We'll just walk us through number 1, explore, and then we'll get another video for the other two. Okay, so very quickly, it says right here, use your graphing calculator. I'm going to cross that off. You can do that too. And I'm just going to put brains. You're going to have to use your brains on this one and your mathematical know-how. Use your brains to help you with this activity. We're going to graph the function of f of x equals 2 to the x power. What that means is that if you took x is 1, okay, x is 1, 2 to the first power is 2. If x is 3, okay, 2 to the third power is 2 times 2 times 2, which is 8. Great job. All right, so you go over 3 right here up to 8. And this is basically your function. It's not going to ever cross that x-axis. All right, this is what the graph looks like. We've confirmed 2 different points. You might want to get a third one in there so you know where this line should go. 2 to the second power, if x was 2, 2 times 2 is 4, so you could do 2, 4. And then you can find out the values here. We don't really need to know that. Just know that it curves like that, okay? These lines look like they're flat, but really they're just going down at such a small level you can't really tell with your eye. All right, so that is our first function. This is what the exponential growth function looks like. And now I want to look at what happens when we change that h in this formula. Function of x equals a times b to the x minus h power. Well, what happens when we change that h value? And I'm just trying to get this perfect, and I'm not going to, but it's close enough, yeah? Oh gosh, this is driving me crazy, guys. Okay, good. Yeah, there we go. Boom. Okay, so what I'm going to graph right now, g of x equals 2 times x minus 4. Okay, now I know you're freaking out. X minus 4, that might give us negatives. Well, let's just do a couple points and see. When x is 0, 0 minus 4 is negative 4. If you do 2 to the negative 4th, that's the same as doing that's the same as writing it like this, 1 over 2 to the 4th, and that would be 16, okay? And you can do that for the other ones too. 1 over 2 to the 3rd, 1 over 2 to the 2nd, 2 squared, 1 over 2 to the first power, and on and on and on. All right, so when you do that, and that's basically if x was 1, then that would be or 0, it would be this. If x was 1, it would be this. If it was 2, it would be this. If it was 3, it would be this. And then obviously if it was 4, it would just be 2 to the 0 power, which equals 1, right? So I'm going to start right there. When x is 4, then we have 2 to the 0 power, or 1. Okay. When we have 5 minus 4 is 1. 2 to the first power is 2. If x was 6, 6 minus 4 is 2. 2 to the second power is 4. And let's just jump up to 8. 8 minus 4 is 4. 2 to the fourth power is 2 times 2, 4 times 2, 8 times 2, that's 4, 16. Okay, I can't really see it up here, so I'm just going to do 7. 7 minus 4 would be 3. 2 to the third power is 2 times 2 times 2, or 8. So we're just going to go 7 and 8 right here. Okay, now I'm not really going to worry about these ones because graphing 1/16, 1 over 2 to the fourth power is 1/16. That's like right here. You can barely tell. And then 1/8 is not much bigger, and then 1/4 is not much bigger, and then 1/2 is not much bigger. So basically this graph is going to go like this. It should follow this green line. And then rise up like that. Okay, so that's what happens when we change h. When we change h, you should see the graph move or translate to the right. Well, it should translate in any case. All right, now let's see what happens when we use an actual, or that's negative, so let's see what happens when we add an h. So we take away an h, it moves this way. Let's see what happens when we add an h. Okay, so we're going to do in a new color. You know me, I love my colors. H equals 2 times x plus 6, okay? Now, I just did that so it doesn't shut off on me, okay? So I'm gonna start with -6. 2 to, when x is -6, right here, okay? 6 plus, I'm sorry. Yeah, -6 plus 6 is 0, so 2 to the 0 is 1. Let's say we did, if x was 0, 0 plus 6 is 6. That might be too much, so let's do -2. Let's do, I'm sorry, -3. So -3 plus 6 would be 3. So 2 to the third power would be 8. So when x is -3, then our value right here is 8, all right? And you're gonna see that this graph is basically gonna go like this. Zoom, just like that. Okay, so I only really chose 2, but I know what the graph looks like, and it's going to follow that same pattern. All right, so when we subtract an h from x, it moves our graph to the right a little bit. When we add an h, it's going to move our geographic function, our exponential function, to the left. It's going to translate it. All right, we're going to compare the 3 graphs. How is a graph of g of x, which is this one, related to the graph of f of x? It is translated to the right. Okay, how is the graph of h of x related to f of x? It is translated, and obviously I should be saying the graph of g of x is translated to the right of f of x, and the graph of h of x is translated to the left of f of x. Okay. Delete all the equations. We did that. All right, I'm gonna delete them. Hold tight. Boom. Okay, and I'm gonna delete this too. If you didn't have it, pause it, rewind, go back. All right, you're still gonna need to use your brains, so don't turn them off. All right, we're gonna look at this. Now we're gonna add that k factor to it. All right, so graph g of x equals 3x plus 3. All right, that is, f of x is 3 to the x power, that goes right here. All right, well now we're going to graph g of x, which is 3 to the x power plus 3. So let's start with 0. 3 to the 0 is 1, right? 1 plus 3 is 4. So when x is 0, okay, so this is my g of x. All right, if I did -1, okay, -1 would be 1 over 3. 1 over 3 plus 3 would be 3 1/3. So when x is -1, we are at 3 1/3, which is basically right here. Okay. When x is -2, that would be 1 over 9 plus 3 would be 3 9. Okay. So we're looking at this, and you can see that this graph moves up on our coordinate plane. It moves up on our coordinate plane. All right, now let's see what happens. That's when we add. Okay, let's see what happens when we subtract a k. Okay, so same thing. If x is 0, 3 to the 0 power is 1. 1 minus 5 is -4. So when x is 0, y is -4. Forgot to change color. We'll go back to brown for this one. Okay, -4. Okay, good. When x is -1, that's 1 and, let's just go, yeah, -1. That would be 1 over 3 minus 5 would be 4 2/3. -4 2/3. All right, when it's -2, that's 1 over 9 minus 5. 1/9 minus 5 would be -4 8/9. So it looks like we're going like this. So this graph is basically going to go okay, and it's just going to grow like that. And probably this curve is a little bit too steep there. That might be a little bit better. Okay, I'm just eyeballing it here. So you see that it translates down. When we're adding a k, when we add a k in the blue, it translates the graph up on our coordinate plane. When we subtract a k, we move the graph down on our coordinate plane. All right, so let's compare the three graphs. How is the graph of g of x, which is this blue one right here, related to the graph of f of x, which is this black one, okay? Graph g of x is translated down the y-axis on the coordinate plane. Okay, and then how is h of x compared to f of x? Oh, I'm sorry, this should be up the y-axis. And graph h of x is translated down the y-axis on the coordinate plane. If you see my volume, if you hear my volume levels getting higher or lower, it's because I realize I might be talking too quietly. All right, so I'm going to give you a chance to see that. Hopefully that makes some sense. Notice the graphs are basically similar. They're just moving up or down that y-axis on the coordinate plane. Woo! Almost ran out of time there. All right, let's go back to black really quickly. And we're just looking, how do you think the value of h affects the graph of g of x equals b to the x minus h power? All right, how do you think the value of h affects the graph? It translates the graph along the x-axis. And how do you think the value of k does it? Affects the graph. It translates it along the y-axis. Okay, now, knowing that, you should be able to, if I give you a graph, if I wanted you to translate it left or right along the x-axis, you should be able to do it by subtracting or adding from our exponent. If I wanted you to translate it up or down, you should be able to create a function that translates that graph up or down by adding or subtracting a k, okay? And go back and review how to do that. All right, that will be the end of part 1. We'll be looking at part 2. This one's a kind of a long lesson, so, just get ready. Sorry it took so long on that, but that is the end of part 1. Peace.